Welcome back to part 3 of your fall final exam review. Now we are going to do some force and momentum problems. So for this section, you will need your science notebook. Open it up to your next available page. You can keep going on your same final exam study guide. You're going to write in all your answers. You will need your physics everything sheet. Comes at the back of this guy, so you can look up all the correct equations and be ready to go there. And you will need a calculator. Personally, I err on the side of a scientific calculator. It's my preference. Graphing is fine. Even a non-graphing regular calculator would be okay. Solar panel is nice for a calculator. Your choice, up to you. Okay. And a writing implement of your choosing. I err on the side of pencils so that I can erase and correct work. Okay, so let's jump straight in. Boom, boom. So we were on our final exam study guide, and we're now down at number 4, forces. So for each of these questions, we're going to go through the question, and then I'm going to ask you to pause the video and attempt to answer it on your own. Okay, forces. If the speeding car has a mass of 600 kilograms, so the speeding car was the red one previously, it was going at 30 meters per second the entire time. If the speeding car has a mass of 600 kilograms, what force does it exert down on the ground? Okay. Try to come up with your needs and givens, a valid equation, and then plug in values and solve. What's the force down that the speeding car is exerting on the ground? Pause and answer. Welcome back. Thank you for unpausing. So let's start with our needs and givens. I need a force, and it's a force down. And what causes a force down? It's caused by gravity. So force down due to gravity, and that can also be called a weight. Okay, so the force of gravity or the weight. I am given a variety of things. I am given the mass is equal to 600 kilograms. I am given the speed of the car is 30 meters per second. And I all know that since this is due to gravity, I know that the acceleration due to gravity is equal to 9.8 meters per second squared. Whoops. Okay. So I have an equation. I need a force due to gravity. My equation is that the force is equal to the mass of the object times its acceleration. Now, since this is going straight down, the force going straight down, it'll be accelerated due to gravity, the same way that I have a force right now pushing down on me. It's pushing on the chair that I'm sitting at, and I can feel that force because I can feel the chair underneath me. So I now plug in my values. Force equals 600 kilograms times 9.8 meters per second squared. And that gives me a final value of my force equal to, plug into my calculator, 5,880 newtons. So my unit there should be newtons because it is a force. And that is also a weight. I could convert it to pounds, but I'm going to leave it in newtons because that is the proper scientific unit. Wonderful. All right. Part B. What force does the ground exert up on the speeding car? Pause and answer. Welcome back. So the force that the ground exerts up on the speeding car, well, I know that every force exerts has an equal but opposite force. And in this case, the car is not sinking into the ground, and it's not being lifted off the ground, so it's in equilibrium. So the two forces have to balance each other. Force down has to equal force up. So based on Newton's third law, every force has an equal and opposite force. I would find a value of 5,880 newtons. Since every force has an equal and opposite force when in equilibrium. That's Newton's third law. Awesome. And then part C, if the speeding car, which is moving at 30 meters per second, crashes into a pile of snow and comes to a stop in 0.5 seconds, what force would be exerted on the car? Pause and answer. Welcome back. All right. So once again, I need, let's see, speeding car, what would be the force exerted? So I need the force. I am given the speed of the car. So I'm given a velocity of 30 meters per second. I am given the mass of the car from earlier was 600 kilograms. I am given a time of impact, right? And that was 0.5 seconds. Okay, so now I need an equation that has force, velocity, mass, and time in it. And if I check on my physics everything sheet and go back a page, aha, I have either the equation for force is mass times acceleration, and I could find acceleration by doing velocity over time of impact, or the one that I'm going to choose to use is my momentum impulse equation, mv equals ft. And that should be a lowercase m. There you go. mv equals ft. So now when I plug in, my mass is 600 kilograms times my velocity, which is 30 meters per second, equals the force, that's what I'm solving for, times the time of 0.5 seconds. All right, so now I need to solve for force. I'm going to divide both sides by 0.5 seconds so that I can get force by itself. That'll cancel the 0.5 seconds by setting it equal to 1. And then I have 600 times 30 divided by 0.5, giving me a grand total of 36,000 newtons. That's a lot of force. 36,000 newtons of force would be my total force. And is that a reasonable force to exert on a car? It is. It crashes in. It might compress my car a little bit because I'm moving at 30 miles or meters per second. That's like 65 miles an hour. Whew. If I go from 65 miles an hour down to 0 in half a second, that might be pretty intense, but that is a valid force. And that would be a force horizontal, right? Exerted on the front of the car. So that's why you have a crumple zone to protect the people inside. All right, minimize or maximize the time of impact to minimize the force on the people. Let's do a few questions about momentum. Number 5. So the first thing to remember is that momentum is always conserved. And that's conserved in an elastic collision. It's also conserved in an inelastic collision in any closed system with no energy lost to the environment. Kinetic energy is also conserved in an elastic collision. So momentum is always conserved. And then kinetic energy is conserved in an elastic collision. And then we have this equation. I could do the momentum before equals the total momentum afterwards. m1v1 plus m2v2 before is going to equal to m1v1 plus m2v2 after. So let's find the momentum of the speeding car. All right, go ahead and pause and answer. Welcome back. All right, So I need momentum, which is P. Okay, I am given the mass of the speeding car. Oops. And I'm just going to do M equals 600 kilograms. I'm also given the speed, the velocity of the speeding car was 30 meters per second. So the equation, when I look up my equation for momentum, momentum P equals, that should be lowercase p, please, equals mass times velocity. So that would be momentum P, no, knock it off. All right, well, it's going to go uppercase because of autocorrect, equals 600 kilograms times my velocity, 30 meters per second. I wonder if I can go back and change it to lowercase p for momentum now. Yeah, take that, computer. So that gives me my momentum equals, got me again, 600 times 30 is 18,000 kilograms meters per second. That's kilograms times meters divided by seconds. And that would be my momentum of my speeding car. If the speeding car crashes into a stopped 1,200 kilogram truck and comes to a stop, how fast should the truck be going after the crash if momentum is conserved? Ooh, okay, so this is a good one. So the speeding car crashes and comes to, and then comes to a stop. This truck is stopped at the beginning and then it starts going. So I'm going to have to use my conservation of momentum equation. And my conservation of momentum equation was m1 v1 plus m2 v2 equals m1 v1 plus m2 v2. Okay, so I'm going to have trouble with subscripts, but I'm going to say m1 v1 plus, oops, m2 v2 equals m1 v1 plus m2 v2. Okay, now my next part is I need to plug in what I've got. So my speeding car is going to be object 1. I'm going to say that's the speeding car. And that had a mass of 600 kilograms times its velocity of 30 meters per second, plus the truck, the stopped truck, has a mass of 1,200 kilograms, but it's stopped. So it has 0 meters per second is its original velocity, right? It's not moving, so it's stopped. And then at the end, the car comes to a stop. It says it crashes into a stop truck and comes to a stop. So the car is now going to be stopped. So it has a mass of 600 kilograms, but now a velocity of 0 meters per second, plus the truck is now moving. So the truck has 1,200 kilograms of mass times its own velocity, right? So times whatever the velocity is going to be. Because that's the question. How fast should the truck be going after the crash? All right. So if I simplify here, 600 times 30, well, I already figured out that's 18,000 kilograms meters per second, plus 1,200 times 0. 1,200 times 0 is 0, equals 600 times 0 is 0, plus 1,200 kilograms times velocity. Okay, now I need to divide both sides by 1,200 kilograms. When I divide 1,200 kilograms by 1,200 kilograms, I get 1. So I'm just left with the velocity, which is what I wanted. That was the goal. 18,000 kilograms meters per second divided by 1,200. 18,000 divided by 1200 gives me 15 meters per second. So my velocity of the truck is going to equal 15 meters per second, which seems to make sense. The truck was twice as heavy, so it's now moving half as fast as the car was moving. So momentum is conserved because the mass times the velocity of the objects at the beginning is equal to the mass times the velocity of the objects at the end. So they balance out and we're good to go. Wonderful. Okay, so that is our momentum and force problems. You will see something pretty similar on your quiz. Sorry, not your quiz, your final exam. And I think you are now ready for your final exam, and that will come out next week. Best of luck, my friends. I think you've got this. So review some of those questions if you need to. Feel free to go back and rewatch and actually do it yourself by hand. And come to tutorial if you need additional help. All right, bye friends, good luck.